Hello students, in this video we are going to study about the physical properties of alkanes. Let us discuss in point wise. First point, that is alkanes are almost non-polar molecules because the alkane having the CC and CH bond which are covalent in nature, and due to very little differences in the electronegativity between the carbon and hydrogen atom. When we take an example of alkane, that is propane. As we know that in alkanes there is a carbon-carbon single bond and carbon-hydrogen single bond. Both the bond, that is CC bond and CH bond, are covalent in nature, and there is very little differences in the electronegativity, because when we compare the electronegativity here, carbon-carbon both are same type of atom, that's why there is no difference in the electronegativity here. And here also, in compared to carbon and hydrogen, very little differences is there in electronegativity between the carbon and hydrogen. That's why we can say that these are almost non-polar molecules because of the covalent nature of CC bond and CH bond, and because there is very little differences of electronegativity between the carbon and hydrogen, therefore these are called as almost non-polar molecules. The next property, that is it possesses weak van der Waals forces. Because there is very less electronegativity differences between the carbon and hydrogen, therefore these molecules are held only by weak van der Waals forces, which is also called as London dispersion forces. We have already learnt about these forces, that is a weak force. So these molecules involves, or we can say it possesses a weak van der Waals forces, which is also called as London dispersion interaction. So because of the weak intermolecular forces, these molecules are gases in nature. Usually carbon 1 to carbon 4 alkanes are gases. Due to the weak forces, the carbon 1 to carbon 4 alkanes are gases in nature. Next, the carbon 5 to carbon 17 alkanes are liquid, and the higher members, that is the alkanes having more than 18 carbon atoms, are solid at 298 Kelvin. So because of these weak van der Waals forces, we can see as the size, because it depends upon the size and the structure of the molecule. So smaller the size, smaller will be the surface area. So we can see that in the lower members, these are usually gases, and when the carbon number increases, then it becomes liquid, and finally if carbon number is more than 18, it becomes solid. So that is what the physical nature of alkanes. Next we are talking about solubility. Solubility, when we compare for alkanes, these are insoluble in water because water is a polar solvent, and we have learned that alkanes are almost non-polar in nature. So they are almost non-polar, so they soluble in non-polar solvents like benzene, ether, carbon tetrachloride, etc., but they are insoluble in water because water is a polar solvent, but being non-polar in nature, alkanes are soluble in non-polar solvents. So because the alkanes are non-polar, therefore it dissolves in non-polar solvents, and we can already learn this word, that is like dissolves likes. Like dissolves like means the polar substance dissolves in polar, non-polar dissolves in non-polar. So being non-polar in nature, alkanes, they are dissolved, they are soluble in non-polar solvents like benzene, ether, carbon tetrachloride, but it is insoluble in water. So that's why we have this we can say that the like dissolves like, that's why non-polar alkanes dissolve in non-polar solvents, and the solubility decreases with the increase in the molar mass. So we can say that the lower members are more soluble than the higher members because the solubility decreases with the increase in the molar mass. Next very important point, that is boiling point. So when we compare the boiling point of the sum of the alkane which is given in the table in the textbook, you can see that the boiling point of methane, which is the first member in alkanes, that is it is given as 111 Kelvin. Next for ethane 184. Next for propane 230.8. So what you can compare from this table, that is when the carbon number in alkanes are increasing, because we can say that when we move to higher members, we can see that the boiling point is increasing. So the least boiling point is for the case of methane because it has only one carbon, that is a lower molecular mass. So here we can the molecular mass is also given. So what we can compare from this table, as the molecular mass is increasing, you can see the molecular mass is increasing for this series of elements, for this series of alkanes, we can say that the boiling point is also increasing. So we can compare the boiling point on the basis of its molecular mass. So we can say that alkanes are generally having low boiling point. That is because of the non-polar nature and the weak van der Waals forces, and with the increase in the molar mass, boiling point also increases. But with the increase in the branching, boiling point decreases. This is because when there is increase in the branching, the surface area decreases. And when the surface area decreases, we can say the boiling point also decreases. So here, when we take an example of isomers like pentane, this is pentane, which is a straight line. Now this one is a branched isomer of pentane, that is 2-methylbutane, and the third one is 2,2-dimethyl propane. So all these are having same number of carbon and same number of hydrogen. That means these having same molecular mass because these are the isomers. So these having same molecular mass, but we can see that there is branching here. So when we compare the boiling point, when you look at here, it is 309 Kelvin, this is 301 Kelvin, and this is 282.5 Kelvin. So what you can see that these have same molecular mass, but they have different boiling point, and that is boiling point is decreasing with the branching, because this is a straight chain, that's why they have higher boiling point, and this one is the branched one, that is having the same molar mass, but it is branched. So as the branching is increasing, what is seen here, their boiling point is decreasing, and again that is further branched, so again the boiling point is decreased. So from this example, what we can compare that with the increase in the branching, boiling point decreases, but the boiling point increases with the molar mass. That is why the lower members have low boiling point and higher members have high boiling point. And the decrease in the boiling point with the branching, that is due to the decrease in the surface area. So this is very important point, that is boiling point. So in the next video, we'll be discussing more details about alkanes. So this is all about this video. Have a nice day.